First of all, welcome everybody to the review meeting. So the one for 1.122 we had to skip because there were too few topics, but now we are back with a 1.123 release. And we start with Luca, who will talk about defaulting machine image versions from a prefix. And Oliver will show us how he simplified the gardenlet deployment configuration. Tim will show a new feature in provider local, which is the Bastion controller. And finally, Ishan will talk about immutable backup buckets. And yeah, with this, Luca, please get started.
Thank you very much, Raphael. So this usability enhancement is actually from the 1.122 release. It's about defaulting the machine image version specified for workers in a shoot spec, also on updates. So formerly, the defaulting only took place when creating new shoots. And now this is also possible for updating existing worker machine images based on a provided prefix. And I can also quickly go ahead and show what this looks like now. So normally if you go ahead and on creation of a shoot entirely omit the version or pass a prefix, if we then apply this shoot, the image version is defaulted or extended based on what the cloud profile offers for the specified prefix. If we would go ahead and now with the new version, update the prefix here and only set it to a new prefix like 2.0, we see it also extends. Formerly this was rejected. And what I can also do, because I have introduced next version only specified 2 again, and I get updated to 2.1.3. So this hopefully eases a bit the operation or the maintenance effort for existing shoots for the owners and makes image version choosing easier. So that would be it from my side.
Cool. Nice small feature. Any feedback? Probably not. Okay. Then thank you, Luca. And over to Oliver. Simplified gardenlet deployment configuration.
Good morning. I'd like to present this pull request here. It's about simplifying the gardenlet configuration. It's based on an issue from Tim. The things he proposed, basically two things, that we simplify the gardenlet resource in two ways. One is that, or both are related to the garden cluster access configuration, and both are removals of fields. First one is, we could remove the garden cluster address because it could be simply derived from the garden resource. And the second one is the garden cluster CIA cert. Yeah, it's basically the same. This was done here by this pull request. So it changes two things, basically three. One is missing. It's just in the release notes. The first thing is here, as I said, you don't have to specify the garden cluster address anymore. It's now calculated based on the first domain of the garden, the first DNS domain of the garden. And we add the API prefix here. And this is also the immutable domain. Yeah. And the second change here is you don't have to specify the garden cluster CA cert explicitly anymore. And if you do so, yeah, it's the gardenlet gets it automatically from the garden cluster. And then you also don't have to update the CA anymore. And the third thing is missing here. It's just part of the release notes. We also ensure we have a new admission rule, which ensures that this domain I just talked about, the first one, that it does not match any SNI domain pattern, because when you choose or select a domain here, it let's say wildcard certificate is used for this endpoint, and the gardenlets don't expect that. They expect the self-signed garden certificate. So it did not make sense before, and now it does not make any more sense. So yeah, there's a new validation for it. Okay. And I prepared a short demo. So basically, I have a cluster here. Yeah, a normal local setup. And in addition to our normal local setup, I started a second kind cluster, which is, by the way, pretty simpler now with our new end-to-end test setup. And now I just try to create a new seed. It takes a while. That's why I started and continue talking. So the new seed, yeah, as I said, it's based on our new dev setup. And when you check the resources we apply here, we come to the gardenlet. You see simply that, that there's no garden configuration specification here anymore. It's yeah. So we see it's this automation should work. Otherwise, we don't see the seed in the garden cluster. Before it worked in one in one scenario when you used the garden runtime cluster as a seed, then you were able to not specify the garden cluster address. But yeah, that's why I created this second seed to demo this. And we can watch here. Yeah. As we see here now, the seed is already created. So the gardenlet has access to the virtual cluster. So it's a kind of a proof that this thing is working. Okay, and while we wait for this, we could go to the second part of the demo. And as you might remember, the second thing is about the garden CA cert. And this should roll automatically now. So let's check. We can, while this is running, we can still get the status quo. So that's the gardenlet kube config. And we select the certificate here. And we paste it just to compare it with a new certificate after the certificate rotation. I will start in a second. So as you see here now, to jump back to the first scenario, so our second seed has been created successfully. And local 2. Yeah, and as in the spec I just showed you before, there's no garden client configuration. Okay. So the next thing I wanted to show here is the certificate rotation. So we have the gardenlet cube config here, and we saved the certificate. And now we are gonna start a certificates rotation for the garden. I just rotate the CA certificate because it doesn't take so long. I think. Oh. Okay. Now the Cube API servers are rolling, so I don't get any result here. It will take a second until it finishes. Let's see if it's fast enough, or we should continue with the next topic. Yeah, okay. Maybe it will take a while. So maybe if you have questions, you can ask them right now. Yeah.
So we're basically now waiting for the gardenlet to be redeployed, right? With a new CA.
So we are when we rotate the CA of the garden, the operator annotates all the seeds afterwards to renew their gardenlet cube config. And now we are waiting here for the CSRs. So when the gardenlet requests a new certificate, a new client certificate, it will raise a here we go. It will create a CSR. And then we should see the new gardenlet configuration with the CA. But here we see it's the local 2 seed. It's not the local 1 seed. Here we go with the local 1 seed. So now we should have a status where there is a different certificate in our cube config. You see it's already a bit longer. So it should be a different certificate now. Just to remember here, the K9S somehow crashed it. So the validity here, it started at 608 before, and now we have a new certificate starting at 712. So the CA rolled, and we got a new certificate for this. Okay. With this, I can close. Thank you for your attention.
Thanks. Any questions for this topic? Nope. Then we continue with the next one, Tim and the Bastion Controller.
Okie dokie. I'm presenting this PR today. It's about implementing the Bastion controller that has simply been missing in the provider local so far. We had no use case for it. So why is this relevant now? And how is this related to GEP 28? So if we check the proposal for the autonomous shoot classes, there's the medium touch scenario. I presented some changes in the last review meeting already. You might remember that we used the infrastructure provider extension and the machine controller manager to bootstrap the control plane machines for the autonomous shoot cluster. So we try to reuse as much as possible of the components that we already have. And when we go through this flow, we will reach a step where we need to access the control plane machines so that we can actually bootstrap the control plane itself. So basically run Garden ADM in it. So as usual with the other shoot classes, the machines are not accessible from the internet, at least typically not. So we would need some form of Bastion host that is accessible to the internet, and that we can jump over to the control plane machines. So the plan is to reuse this Bastion mechanism that we already have and most provider extensions already implement. And that's why we now implement it in provider local so that we can run this medium touch scenario locally with the local setup. So that's why we're doing it now, but as such, this PR doesn't touch anything related to autonomous shoots. It basically just implements the actuator interface for the Bastion controller of the extensions library. And with this, we can then use it in the local setup. Okay, so I have prepared a shoot in my local setup. And right here in this pane, we are watching ports, services, and secrets of the Bastion in the control plane namespace of the shoot. So when I target my local shoot using gardenctl, I can now use the gardenctl SSH command. This basically creates a Bastion resource next to the shoot in the project namespace. And for every Bastion in the virtual garden, the gardenlet will create a Bastion extension resource in the control plane namespace. And this is exactly what the controller acts on that I implemented in the PR. So now that this happened, we can see there is a new pod, Bastion dash something, so the name of the Bastion. This one, acts like a Bastion VM in a cloud infrastructure. And just as we do with the machine pods, we use a kind-like image to basically run a dummy VM if you want. So there's systemd in it, and we can run the SSH daemon. Then there is a service belonging to the Bastion. This one has type load balancer because we need to have some way of accessing the Bastion host from outside the cluster. And that's where I figured we can reuse a load balancer service. We already have some network magic in the local kind cluster because there is no real load balancer implementation. So there are some hacks in place that map specific services to predefined external IPs. So if we check the Docker container that I'm running, there should be this node port mapped to the 222 port on my machine. And this is how I can then access the Bastion from the outside. So in a typical cloud provider implementation, you would just attach a public IP to the VM that you created, and then you can access it This way, you wouldn't fiddle around with load balancers because there's only one machine, so nothing to load balance. Okay, last part of the Bastion controller implementation is a secret. This is basically the user data that we pass into the Bastion controller, Bastion pod, sorry. This is also similar to how we do it for the machines in the local provider. Okay, all of this got ready. We see the external IP of the Bastion was reported back to the Bastion object in the Garden cluster. And that's why Garden ADM now knows that the Bastion is ready. So after confirming the SSH checks, I can access the shoot node where I wanted to go. So as you can see, this is the machine, and I'm logged in as the Gardener user, just as with any Bastion implementation on the other provider extensions. Because of this load balancer magic that we're doing right here, there's a limitation that you can only use one Bastion in the local setup at the time. So after cleaning it up, you will be able to create a new one, but there's only one IP that is statically mapped to the host machine. So that's why you can only use one Bastion at a time. The other restriction that we have is that there is a back ingress section in the Bastion. This one defines access control list, basically, so allowed IP blocks that should be able to access the Bastion VM. So in the local setup, there's no way of performing client IP restrictions. So that's why this field is simply ignored. It's just worth mentioning, probably.
क्या चाहती हूँ मैं नहीं यूज करूँ तो मैं नहीं यूज करूँगा मैं 300 खरीद लूँगा.
Sorry, I don't think this was a question to the topic. Okay, so let's put the watch back on. After terminating my SSH connection, Garden CTL cleans up the Bastion resource in the garden, or at least marks it for deletion. And that's when gardenlet and the provider extension take care of cleaning up all the resources belonging to the Bastion. And with this, my demo's finished. Are there any questions?
Maybe you can once again explain why we do that when there is a simple kubectl exec command that we could use in the local setup.
True. Yeah, in the local setup, you could just exec into the machine pod, right? That's probably what you would do when debugging something in the local setup because it's much easier. But again, we need some way to have an implementation of the Bastion resource in the local setup so that we can progress with the medium touch scenario. Otherwise, we wouldn't need this because it's obviously easier to use kubectl exec. But we don't want to put any special cases related to provider local in Garden ADM or other components. That's why we try to fake as much as we can in the provider local extension.
Yeah.
Another small question, do we intend to change this to allow users running on Linux to actually run it? Because we use port 22, which might be used on some Linux machines for SSH.
Is this a problem if you only open the port 22 on a non-127 IP?
I think at least some internal colleagues had issues which were running on Linux. That port 22 was already used basically, and then you get then the Docker daemon cannot bind to it, even though it should just bind to separate IP, but yeah.
Oh, interesting. I wasn't aware of this. If there's an issue with the problem description, we can probably take a look.
Okay.
Good. If there are no further questions, thanks to Tim. And let's hand over to Ishan for the last topic for today, immutable backup buckets.
Okay, my screen is visible.
Yep.
Okay, so hello everyone. I will be presenting the immutable backup. It's a joint effort. For Azure, Saket worked on Azure Blob Storage. Google Cloud Storage worked on Shesha worked on Google Cloud Storage, and for S3 I worked on S3. Okay, let's start. So why immutable backup? So basically, currently or before this feature, anyone was able to delete or modify our backups, and that should not be possible. So our motive is to our snapshots or backup should not be deletable, or any kind of modification should not be possible. And any solution should apply for the existing backup bucket as well as newly created backup buckets. And will there be any cost implication? Although the cost is very least priority on this, because it's a security thing. So security overtakes the cost, but still, what will be the cost implication? So providers provide something known as lock mechanism to lock the objects. Every provider is using different terminologies. Basically, some is using object lock, some is using bucket lock, some is using worm. Worm is write once, read many. So I will be using the bucket lock terminology or immutable backup. So basically you have the snapshots, full snapshot 1, 2, delta snap 1 and 2, and you enable the bucket lock, which is based on the worm model, write once, read many model, and your object will get locked. Technically, this picture is wrong. This is more correct. So basically, you enable the object lock, but all the old objects, which is full snapshot 1 and delta snapshot 1, will not get locked. So before enabling the bucket lock on the bucket, all old object will not get locked. Only the newly created object will inherit the settings which you set on the bucket. So only the new object will get locked. Yeah, but eventually these old objects, which is full snapshot 1 and delta snapshot 1, will get garbage collected by the garbage collector or backup restore, because it continuously run. And it's fine, because the full snapshot 2 is kind of a superset of full snapshot 1. So we are fine with, because we have the bigger full snapshot which is locked. But eventually you will get lot of logged snapshots. So lot of snapshot will get logged. Eventually your bucket will keeps on growing. So you still need to delete the snapshot, and that's where the retention period comes in. Let me minimize. Okay, so retention period comes in. So retention period is a kind of a duration for which snapshot is immutable. The snapshot is locked, and after that immutability expires and it becomes unlocked, and you can garbage collect. Okay, so yeah, so for example, full snapshot 2 is uploaded at day T. On full snapshot is next day, T plus 1, T plus 2, and let's suppose retention period is set to 4 days. So after 4 days, full snapshot second will become unlocked, and hence you can garbage collect. And as I mentioned, now we have to change the garbage collection of all providers handled by the backup restore for S3, Azure, and well as for GCS. Now, although if we don't change, they just nothing will get impacted. They just log the error, but it does not look good. So now the backup restore garbage collector will check whether the snapshot is deletable or not. So there is a time stamp. It just calculate, and yeah. Now things get little diverge here. As I mentioned, different providers are using different way, implementation. For Azure and GCS, things are quite simple. Your snapshot still looks the same. Your objects still look the same. It get locked. You can't delete. You can modify, but nothing changes from the visual perspective. So nothing changes for the restoration, upload, and everything. Nothing changes from that side. For S3 is basically S3 is achieving bucket lock functionality via versioning. So you have to enable versioning as a prerequisite for enabling bucket lock. So as I can show, as I am showing that fully, I will show in the demo as well. When you upload a full snapshot, it will assign a version ID. And those snapshots which were uploaded before versioning was enabled, they will set as version ID as null. So what S3 says is I am locking a version of that particular object. So hence we have to change the restoration functionality of backup restore. Okay, so now I will show you the issues. So we have to change the functionality of the restoration for S3. How the S3 is how the restoration will work with the with the versioning, which can contain non-versioned plus versioned objects and anything like all versioned, all non-versioned. So it is backward compatible as well. Apart from this copy backup task, like copying the backup from one version enabled bucket to the non-version enabled bucket and so on and so forth. Yeah, so this was changes done for the backup restore side. Once it is done, we came on this to enable the immutability on backup bucket. So this we are doing it via gardenlet extension provider extension. I will show you. So basically, there's a resource backup bucket resource which contain the infra, which contain information for backup bucket infra, and backup bucket controller acts on it and updates or creates the backup bucket accordingly. So it has a region, reference to the secret, and something known as provider config. So basically, provider config is for provider specific configuration, which comes as a raw extension. And what we have done is we have defined a schema for this, and we will decode this. And once this provider specific configuration is provided in the backup bucket resource, extension backup bucket resource, we will decode this, and backup bucket controller decode and updates the backup bucket accordingly. So I will just tell retention type, as I mentioned, it's on type bucket. So you set the on settings on bucket level, and all objects will inherit. All the newly created objects will inherit that settings, just like a parent-child relationship. Retention period, as I mentioned before, there's something known retention period. Currently, it is set to 4 days. Why 4 days? Because currently we are retaining our delta snapshot for 4 days. And if you have remember that whenever a shoot owner delete the shoot, the grace period is for deleting a backup entry is also 4 days. So it makes sense to have 4 days, and now 4 days also solves our cost implication issue. So nothing from the cost side. There is something known as locked. It's a Boolean indicating whether a bucket retention policy, immutability policy is locked or not. So terminology wise, they are using a retention policy. So it's little changes. So retention policy locked or not. So what provider says is, if your retention policy is not logged, you can abort this object lock settings on the bucket. Let's say you enable the object lock on the bucket, but it is not working as you expected, then you can revert it. But once it is logged, once the retention policy is logged, you cannot go back. Your retention period cannot be decreased. It can only be increased. So let's say we have set it to 4 days, so it cannot be decreased to 3. It can only go 4 to 5 and all. And this is true for Azure and GCP, but this is also not true for AWS. So AWS has nothing as like log policy or not. It has something known as the things are same: retention type, retention period, something known as compliance mode and governance mode. So governance mode is like some user can delete the snapshot. Compliance user, no user can delete the snapshot, including the admin or root user. Okay, so I will show you the demo. This is my seed. I will be showing this for the second seed, and this is my backup bucket. Okay, I will show you my backup bucket, how it looks like. I have created one shoot. I can show you the properties. The bucket versioning is currently disabled. Object lock is also disabled, so we haven't enabled it. And if we go back, we have one shoot as well. And this I will be doing this for this seed. Okay, so nothing is left here. So what I will do is I will update the spec of seed with provider config. Let me copy it. So I will be updating for bucket and 24 hours with 1 day and compliance mode. So it has the admission well book as well. So you can't just put something like which is not valid. And once it is done, it will copy my gardenlet reconciles and it, okay, I forgot to put a watch. I put a watch on the backup bucket. So so the gardenlet reconcile, it copies the spec.backup to the backup bucket, core backup bucket, and it get copied to the backup extension backup bucket. Yeah, okay, it got copied. And I will check my bucket, and versioning got enabled and object lock enabled with a compliance mode with 1 day. Okay, so I will show you what, see, this little button was not coming before, show version. So now because the versioning is enabled, so this little button you can enable it, and you will see the version ID. Version ID is, as I mentioned, these are the objects which were uploaded before enabling it. So that's why they have a null. So what I will do is I will just exec into my etcd, and I will trigger a full snapshot. So now this full snapshot is getting uploaded after bucket lock has been enabled and versioning has been enabled. Okay, so I can refresh. As you can see, a full snapshot was taken with a version ID is assigned. Now, if I click on this again, version ID is not shown. So if I click, I want to show you how the versioning is behaving. If I click on the delete button and write delete, it will let me delete. So don't get scared that you say it is locked, but now you're letting delete. So, but the thing is, as I mentioned, every object will result into a different version. So once I click back, you can see my snapshot is backed. It just S3 has put a delete marker on the top of my object, and by backup restore is smart enough to ignore these delete markers and all. So if I click on this again, now I'm try to delete a versioned object. So if I click on this and try to delete, so there's a difference between delete and permanently delete. So now I can't. So I can't delete objects because immutability. Okay, so one more thing I can show you is deletion of shoot. So okay, shoot is running on this namespace. So once I trigger a deletion of shoot, the backup entry controller try to delete the backup entry, according to the grace period, which is set to 0 in local setup. It is set to 4 hours in dev landscape. It is set to 4 days in our production. So, but now the thing is, we have the immutable backup. Now, how the bucket entry will get deleted? And this is the same scenario is used in the CPM when control plane migration triggers control plane migration from source to target. It tried to trigger the deletion of all resources in the source, including the backup entry. Now you can't because you have the immutable backup, and which are logged. Now you can't delete all the resources. So what we have done is, let me trigger the deletion, and I will talk. I have triggered the deletion. Now the backup entry controller will see whatever the snapshot it can delete, it will delete. Whatever the snapshot it can't delete, it won't delete. Okay, let me exit as well. It won't delete. It will tag the snapshot, and it will create a lifecycle policy to the and add it to the uh, on the bucket. Now the lifecycle policy will see, okay, these snapshots are tagged, and I will garbage collect these snapshots. And this is how the same process is done for the normal should deletion as well as for the CPM. When it checks, when it does snapshots, it can't delete. It won't able to delete. But it moved its responsibility to the lifecycle management of the bucket, add the lifecycle policy, and saying that the only act on those snapshots which are tagged. Okay, once it is done, I will show you. So these snapshot, these are null. So backup entry deletion will able to delete this snapshot. But as this snapshot is I just uploaded, and this is the immutable one, this won't be able to delete. So deletion of shoot is done. I can refresh, and I will show you that all the snapshot will be gone. Only snapshot which are logged are left. And I can show you, maybe got tagged. Yeah, it got tagged garbage collection marked for deletion. And we can go to the bucket and check the bucket management. We have the lifecycle policy. Y2, as I mentioned, S3 is working little differently. For Azure and GCS, there is only one lifecycle policy. We have to add two lifecycle policy to completely garbage collect all the object for S3, and that's why we have two lifecycle policy. If you are interested, then maybe I can explain you ad hoc, but it is a little more complicated. Why we have two lifecycle policy, and this backup entry will get automatically deleted by the lifecycle policy. Okay, yeah, that's it from my side.
No questions to the topic?
I have a short question. I've seen the user, the backup bucket user, it changed the settings of the backup bucket. So to versioned and to the retention period, it said a retention period. Is it able to change it back so that a potential attacker could simply revert the steps, remove versioning, and set the retention period to 0 and then delete everything?
No, the version once you enable, okay, for Azure and GCP, once, as I mentioned, there's no concept of versioning. Once you lock the retention policy, you cannot disable the bucket lock, and you cannot shorten the retention period. So you can only go 3 to 4 days. For S3,
Okay.
you cannot disable the versioning, but the thing is, and you cannot decrease the retention period as well.
Mhm.
And and we have the admission webhook as well on the seed, that once it is applicable, you cannot remove the spec.backup from the seed. Yeah.
Okay. Yeah, thanks.
All right. If there are no further questions, we can close the session for today. Thanks everybody for joining. Thanks to all presenters, and see you again in 2 weeks. Have a nice time. Bye-bye.
Nice time. Bye-bye.
Thanks a lot. Bye.
Bye.
Bye.